Back for more, eh? We're now going to look at the three world famous special products and what they mean. We're also going to look at some examples and we'll do one example on how to solve an equation. Let's do it. So we're back to special products now, and before we start, do we remember what they are? Remember there are three of these special products. A plus B all squared. What is that? That is a squared plus 2ab plus b squared. Remember, this is not true. It is not a plus b all squared, a squared plus b squared. That is not true. Why? Would you like me to demonstrate that? I might just demonstrate it because I don't think I got around to doing it last time. Let's say I have something like this. I want to do 3 plus 1 all squared. What is it equal to? I'm going to do it two ways, and I want you to tell me which way is the right way and which way is the wrong way. So if I do it this way, okay, what is this actually equal to? 3 plus 1 all squared. Let's just figure out what the right answer is first. Well, how would you do this if this was like a PUMDAS problem or a BEDMAS problem? What do we do first? We do the brackets. 3 plus 1 is 4. And then we do the exponent. 16. So 16 is the right answer here. We know the right answer is 16. So if I do it this way, will it give me the right answer? 3 plus 1 all squared. So is it 3 squared plus 1 squared? What's that? That gives me 9 plus 1, which is 10. Is that equal to 16? No, this is not right. Okay, so remember, that is not equal to that. That is not equal to that. Try not to make that mistake. You'll probably make it once somewhere, but try not to make it twice or more. What is the right way? Okay, well, how do I get 16 then? I've got to use this special product. A squared, so A is 3, B is 1. A squared plus 2 times A times B plus B squared. Let's nut this out. 3 squared is 9. 2 times 3 times 1 is 6 plus 1. 9 plus 6 is 15 plus 1 is 16. Yes, so this is the right way, okay? This is how we do that. All right, so that is why these special products work. The first one anyway. And what were the two other ones? A minus b all squared. Remember, this and this are very similar. It's just this plus becomes a minus and this plus becomes a minus. That stays the way it is. A squared minus 2ab plus b squared. If you can't remember where they came from, I think I explained them and derived them for you. You can always go back and look at that video again. And this one, a plus b times a minus b. Oh, that's wrong. That shouldn't be there. A plus b times a minus b is a squared minus b squared. Okay, we only get a binomial there. These two become trinomials and we only get a binomial here. But today we are not doing that expansion stuff, right? We are not determining what the product is. We're going backwards today. We are factoring. So we're going to be doing this process. What if we see something that looks like that? We want to get back to this. Or we see something that looks like this. We want to get back to this. Or something that looks like that, we want to get back to that. So today we're going to use the special products again, but we're going to think in the reverse order. So let's think of them like this. A squared plus 2ab plus b squared factors to a plus b all squared. And similarly, a squared minus 2ab plus b squared will factor to a minus b all squared. A squared minus b squared, if we see something that looks like that, that will factor to a plus b times a minus b. Okay, boys and girls, so they are the special products. The way we are going to use them for this lesson. So let's try a couple of examples. How do we do these? Here we're going to factor the missing word there. What are we factoring here? What are these things called? Here we've got a trinomial. Here we've got a binomial, and here we have a binomial. So we can't say binomial, trinomial. What's the most accurate word we can use here? These are all polynomials. That's as detailed as we can get for that description. Factor the polynomials. So remember what factoring means. The answer is going to have brackets in it. It's basically going to be some sort of a product. So x squared minus 81. Which of these does it look like? Does it look like that? Does it look like that? Or does it look like that? Obviously, it's going to be this one. So we've got the situation here where A is x. And B, if B squared is 81, what's B? B is 9. So it's going to factor to A plus B times A minus B. Alright? A plus B, x plus 9 times x minus 9. And that is your answer. Another way you can think about it is, for your first step, what's another way that can be written? That can be written as x squared minus 9 squared, a squared minus b squared. So it factors to x plus 9 times x minus 9. What about this one? Same thing, okay? Which does it look like, this one or this one or this one? Obviously that last one again. So what does that factor to? If you would like a line in between here, how could you write that? So it looks like this, something all squared minus something all squared. Can you see that this obviously is 7, but what would go in here? What squared equals 64 and what squared gives y squared? That would be 8y all squared equals 64. Okay, because remember when we're doing this, 8y all squared, that becomes 8 squared y squared, which is 64y squared. Okay, so we're squaring the 8 and the y. That's not finished yet though, that is not factored. Well, if we're going to make this look like this, we now do that step. Okay, so here A is 8y and B is 7. So A plus B times A minus B. So if you did FOIL on these, you would end up with what we started with here. Okay, so there's B. C, which does this look like? This one or this one or this one? Okay, obviously this one's going to be the top one. And what are we going to have here? So A is obviously going to be x, B is obviously going to be 3. Okay, but how do we know that it's a special product for sure? Well, you also have to check. If A is x and B is 3, is this 2 times A times B? What would that be here? 2AB, that would be 2 times x times 3. 6x. And is that what we have here? Yes, it is. So we can use this special product. The answer is simply a plus b all squared, x plus 3 all squared. So again, if you did FOIL on that, if you did x plus 3 times x plus 3, expanded that out, collected the like terms, you would end up with this. Okay, so that is how we factor using special products. Let's have a look at a couple more. D, E, and F. Let's try D here. Which one does, so 4n squared plus 20n plus 25, which of these three does it look like? Obviously the top one. So what are we dealing with here? So this is a squared. If a squared is 4n squared, what's a? A must be 2n. And if b squared is 25, b must be 5. And is this actually a squared plus 2ab plus b squared? Let's check that that works. 2ab would be 2 times a, 2n times b, which is 5. 2 2s are 4, 4 5s are 20n, and that's what we have there. Yes, so this is a special product factorization here. So this factors to a plus b all squared. A is 2n plus 5 all squared. By the way, when we do this, and that works, what we say, we call this a PST. That is called a perfect square trinomial. So in other words, the number 9, that's a perfect square, right? That's 3 squared. 16 is a perfect square, that is 4 squared. 81 is a perfect square, that is 9 squared. We have a trinomial that's kind of like these numbers, okay? It factors into something all squared, and it's perfect. Okay, so a perfect square trinomial, a PST. E, let's try another one. By the way, yeah, you can still use the cross method for these. All right, just doing, if you're not too confident with these or you want to check your answer, you can still use that cross method, okay? Put factors of 4n squared here, 2n, 2n. Put factors of 25 here, 5, 5. Cross method, 10n. 10n. We want two numbers that add to give 20n. Do these work? Yes, that's all perfect the way it is. And we get 2n plus 5 times 2n plus 5. And that can be simplified to that. Okay, so always try and write it like that if you can. E, which case is this? This one, or this one? There's going to be the second one with the minus. So what would a be here? If this is a squared, that can you see that a would be 3c and that b would be d? D. And does this work? 2 times 3c is 6c times d is 6cd. Yes, this works. Okay, this is a special product factorization. So it's going to be a minus b all squared. A minus b all squared. Oh, by the way, I'll just box my answers here. That's simple. F is a little tricky though. This could be a multi-step question here. If I'm just going to factor this, remember what's annoying about that? That minus at the front's annoying, right? And they're all even numbers, so we can take out a common factor here. What can we take out? I'm going to take out negative something. I already gave that away because they're even numbers. And then what would go inside? And then that could be factored into a perfect square, minus something all squared. Something there, something there, something there. And there's a plus or a minus here. I don't know which one is it. Is it a plus or a minus? Let's make that our community question, okay? Let's put your answer for that in the comments, okay, to this lesson post. What's the answer for F? Okay, when that is fully factored. So this is a case of, that's factored, but it's not factored completely. It's not fully factored. You need that full step there, okay? Put your answers in the comments for that one. As I've been doing so far, let's finish with a question where we have to solve it. So here we don't have an expression, do we? What do we have here? We are solving the equation. So very important. There's a difference between solving an equation and factoring an expression. When you're factoring an expression, your answer just has brackets in it, right? When you are solving an equation, your answer is x equals something or x equals something. So this one, we're going to use our zero product property again. So something times something equals 0 means this equals 0 or this equals 0. How can we make this look like that? Well, the first thing, we're going to move that over there and get 0 on the right side. 25x squared minus 4 over 9 equals 0. Now can this factor on the left? Does this look like one of these? Yes, it looks like the third one. Okay, so this is going to factor into something. Something equals 0. So this is going to be our a squared. A squared is 25x squared, which means a is what? 5x. B is 4 over 9. Sorry, b squared is 4 over 9, which means b is 2 over 3. So knowing that, let's factor. What does this remind you of? So we said that looks like this one, doesn't it? So this is going to factor too. A plus b times a minus b. A is 5x. 5x plus b is 2/3 times, and 5x minus 2/3 equals 0. And there we have our zero product property. Okay, we've got something times something equals 0, which means this could be 0. 5x plus 2/3 equals 0. And let's solve it. Take the 2/3 over there, negative 2/3. And how do we undo this? 5 times x. We want to get x alone. So we're going to multiply 1 over 5 on both sides. Cancel, cancel. Leaves us with x equals negative 2 over 15. And let's do the same here. So this equals 0, which gives this solution. Or this equals 0. 5x minus 2/3 equals 0. 5x equals positive 2 over 3. I've got 5x, but I don't want 5x, I want x. So I undo this 5 times x by multiplying by 1 over 5 on both sides. Cancel, cancel. X equals positive 2 over 15. Okay, so they are our solutions, or our zeros, or our roots of this equation here. X equals negative 2 over 15, or x equals positive 2 over 15.